Thank you very much. It's a pleasure to be here, back here actually. I was here before. And to advance the slides, am I going to do that or am I just going to tell someone to?
So the PowerPoint is
yeah.
It's put in
oh, it's here. Got it. Okay, perfect. Thank you. Okay, so the theme of the day is Web3. And so what I wasn't sure exactly what to talk about, so I thought I would try and give a background, a motivation, sort of set the tone for the day. And then, because I know there's intersections here with the legal community, criminology, and things like that, there's a particular topic that I really wanted to talk about. We got good feedback when we talked to other people. And so I'm going to go through what's called central bank digital currencies. Okay, I'll just acknowledge my funding and partners. And the animations are going to be a little weird because I always do my slideshows in Keynote, and then they got exported to PowerPoint. Okay, so what is Web3? So let's just sort of start with a definition. So the idea of Web3 is meant to sort of invoke this idea of the web version 3. Okay, so that's why it's 3. And so if there's a web version 3 that we're all here talking about, that implies that there was probably a web version 1 and a version 2. So what are the version 1 and version 2? Okay, so I'm going to hope this works. Okay, okay. So web version 2. This is just Gmail, and sorry, this is what Gmail would have looked like around the start of the internet. Okay, and so you can still access this sort of stripped down version of Gmail. But as you can see, everything is on its own web page. Okay, so I click a link, I go to the next message, and it loads a whole new website. Okay, it comes down. There's images, there's text. I want to do something else. I press it. It loads another website, okay? So this is still a pretty feature-rich website. There's a lot happening on the server in order to generate these websites. But from the user's perspective, it's just, give me this web page, give me this web page, give me this web page, okay? And so now we're used to Gmail looking kind of like this. And so now when I click on things, it doesn't reload the whole web page, right? It's responsive. It's almost like there's an application running in my browser. So that's the move from Web 1 to Web 2. So originally websites were static, they just displayed content. Now websites kind of run code in your browser itself. It feels more like an application that's actually on your computer. The technical difference is that there's a lot of what we call client-side scripting that's happening. So the website tells your browser what to run the code, and then it runs inside the browser itself. Now, Web 2.0 is not an actual upgrade. Okay, there was no committee and they said, okay, here's Web version 1 and here's Web version 2. It's just a marketing term. It's sort of a buzzword. The media latched onto it. There were conferences called Web 2. It's more of a sort of paradigm shift as opposed to an actual technical upgrade. So Wired Magazine says, this is in 2005, around the time that the term was becoming popular, no one may be able to agree on what Web 2.0 means, but the idea of a new, more collaborative internet is creating buzz reminiscent of the go-go days of the late 1990s in the 2000s .com boom. Okay, so what's Web version 3 then? As soon as someone put the label Web 2.0 out there, everyone started thinking, okay, what's Web 3? What's Web 3? What's Web 3 going to be like? And so there's actually like 2 attempts, okay? So the first attempt is what is called the semantic web, or Web 3.0, okay? And it's really hard to describe. I took a whole course in my PhD on just this topic, and it's hard to like sort of capture it, but the idea was sort of that the browser wouldn't just display content, it would kind of understand what it was displaying. It would know relationships between the data that it was displaying. And so how does the browser come to understand what it's displaying? Well, the person that's putting the website together, they have to sort of prime the browser by encoding a bunch of metadata into it, okay? So the website comes down. It's a lot of extra work for the developers. They're encoding all the things that they want the browser to understand, because the browser is just a machine. It's not a human. It can't look at it and infer what it's supposed to mean just by looking at it. The semantic web, there was lots of standardization. People were excited about it. Then it kind of died out. By the time I was taking my PhD, it was kind of like no one it was sort of a dying field, I would say. And now it looks like probably machine learning will kill it off completely, because now a machine can look at a website and understand what it means by inferring it. It doesn't need the developer to put all this extra meta information into it. So that's probably a much better approach to doing this, okay? So this whole version basically never materialized, okay? So we don't have the semantic web today. We have a bunch of standards, and there's maybe a few obscure websites that use pieces of it, but basically this doesn't exist, probably never will in the way that it was envisioned. So that left the term Web3 sort of free for grabs again. Okay, so the first kind of attempt at finding the next generation web failed. And so then what people did is they latched onto this idea of, when blockchain came out, well, we could call it Web3, okay? And so the Web3 now is some sort of, it has something to do with this blockchain technology, which I'm not necessarily going to assume that you know, so I'll go through it just in a few slides. So the idea of a blockchain is it's a bunch of computers or servers, and it's going to run computation for you, okay? And so you have all these computers, they're all over the world, and the closest thing to it maybe is something like cloud computing. So cloud computing also, you have a big network of nodes, and you have some computation that you want run. And in cloud computing, what will happen is the service will give you the closest server to you. Okay, so we'll find some server, and it will say you run that computation on behalf of the user. It will run it, and then you'll get the results back. Okay? Now, what happens in blockchain is very different. What happens in blockchain is that all the servers run the computation. Okay? Then what they do after that is they come to an agreement that the correct output of this computation is whatever it is. We'll call it Z. Okay, so they do this consensus mechanism, as it's called. Okay, now if you look at this picture, right, I hope you think, wow, this has got to be the slowest thing in the world, right? You have thousands of, or hundreds or thousands of these things, and they're all running, and it's true. It's a terrible, terrible system in terms of performance. Okay, so you can only pass around small data. So for example, in Bitcoin, you pass around 5 megabytes every 10 minutes. 1 megabyte every 10 minutes. A typical song that you might listen to, like an MP3 file, might be 6 megabytes. So it would take you an hour to pass around a song. So it's absolutely not for big data. If you go talk to database people, they spend a lot of time optimizing the database so that you can do fast queries, and you can find all the people that are in this age range and this salary range that have these properties, blah, 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 blah. Blockchains don't have any of that. It's just give me everything. You download it and go through it. Okay, so this sounds like the worst it sounds like the worst database ever, right? So what's it good for? Why are people excited about it? Well, the trade-off you get is very, very high security and integrity. Because every node is double-checking the computation, you're reaching a consensus on it. You can tolerate some of these nodes going offline. You can tolerate some of them being malicious. They could be attackers. And as long as they don't control a majority of the nodes, you're still going to get the correct result, okay? So there's certain types of use cases or applications where you care a lot more about integrity and correctness than you care about performance, okay? So big data is not one of them, but things like finance, right? So if you're doing a payment system, this is good. Payment data is small. It's just Alice sends Bob this amount of money, right? You don't need a lot of data to capture it. It's maybe slightly slow, okay, because it has to pass around the network. Maybe you want a payment system that's a little faster. But what the payment system can do is it can fully clear and settle a payment, even if it takes 2 minutes, 30 seconds, 10 minutes, something like that. That's still pretty fast for a complete finalization of a transaction. Banking systems that have databases, they work very fast, but there's often a sort of back settlement and payment that happens behind the scenes that could actually take days, T+1, T+2, T+3 days, in order for it to actually be finalized. Okay, so Web3 sort of there's two ways that people use it. Sometimes people use it in a broad meaning. That's probably like kind of the theme of the day, which is just that it's kind of the word that encapsulates all this stuff like blockchain, cryptocurrencies, distributed ledgers, smart contracts, all of that kind of stuff. And then if you want to get really picky about it, like what exactly what's the difference between Web3 and blockchain, then you can think about the narrow meaning of the term. And so the narrow meaning is it's kind of the user interface that the user gets when they use the blockchain. So users don't want to, they don't want to type method and then X and then pass it into a smart contract and have to know the address of the smart contract and all that stuff. Users aren't sophisticated like that. What users want is they just want a website. I go to a website and it kind of looks like all the other websites that I use and I use it, okay? But what's different about this website is normally your data is stored on the website itself. So I go to Gmail, Gmail has that data. So when I see my inbox, it's because Gmail's holding on to it for me and they're giving it to me, okay? Here, the websites are sort of empty skeletons. They just define the layout of the page, but they don't actually have the data. Okay, the data is not coming to you from the person that puts up the website. The data is coming from two places. One place is from the blockchain. Okay, so there's a bunch of data on the blockchain, but the data on the blockchain is about everyone, and it's kind of anonymous, and no one knows whose data it is. So if it wants to show me something, like say my user balance, it has to know which address belongs to me. And so what I do is when I'm running the website, I'm also running another piece of software on my computer called a wallet. Usually it's sort of baked into the into the browser itself, okay? And that has my personal data on it, okay? So when I go to a Web3 app, what it's doing is it's basically weaving stuff from my client, and I have to give it permission. So at the very first time I go to the website, the client's going to say, okay, this website wants to know what your address is. Are you willing to share it, yes or no? And I say yes, and then it's like, okay, then it pulls my address in, it pulls all the data in from the blockchain, okay, and then it weaves it together, and then it displays something that's only for me, right? That's personalized to me. But the website itself didn't have that data in the first place, okay? So it's all being constructed client-side on my browser, more or less. So what it looks like is maybe something like this. So this is like a thing for collecting digital art called NFT. MetaMask is the wallet. It's a very common wallet software that you use. It's kind of up in the toolbar. You can see like a kind of fox icon. And so when you click on it, that displays, that's like your actual client that has all my keys. And so once I give permission to this website, then it shows this is the artwork that I personally own. Okay, so the website that I OpenSea in this case, they don't know what artwork I own. Okay, so that information came from my wallet. And then once they had that information from my wallet, they went through the entire blockchain. They found every piece of artwork that everyone owns. They threw away all the ones that didn't belong to me, and then they pulled in the ones that did belong to me, and then they display it on a website like this. Okay, so what does this allow you to do? So this whole like kind of Web3 paradigm combined with blockchain, the sort of high level sort of the sort of 30-second version is, imagine you had some, it could be a financial service, it doesn't have to be limited to finance, but you had some idea for some project that could run in code, it could run autonomously. Then what you can do is, if you can code it up, you can give it to this network, and this network is going to run that for you, okay? Forever. You could just hand over the code for your application. You could walk away, never touch it again, and it's just going to run in perpetuity. As long as people want to use it, they can continue using it, okay? So it just sits there waiting. And there's, and the guarantee is, it might be slow because blockchains are slow. It can't do really super fancy things because there's computational issues if you try and do things that are too fancy. But if you can find something that meets this definition, then it will run exactly as it's coded. Okay? Now, that's in and of itself a very carefully parsed out statement. It doesn't mean that so it gives you a security guarantee. So the security guarantee or correctness guarantee is the way it's coded, that's how it's going to run. Okay? Now, does that mean it's coded correct? Not necessarily. So you could still have security vulnerabilities in a blockchain app. It's not because the computers were malicious and they're doing bad things. They're running your code exactly as it was coded. It's because you did something wrong when you coded it. Okay, so I'll tell you a story about that in a second. But anyway, so today, as of today, there's about 40 billion US dollars locked up in all this stuff that's happening in Web3 on Ethereum. Ethereum is one of the largest blockchains that lets you do this sort of general purpose smart contracts. So 40 billion is not a huge number. If you think of financial markets and equity markets and derivative markets and things like that, this is very small compared to it. But if you think about the market cap of businesses and even countries, GDPs of countries and things like that, this is a material amount. So it's enough, I think, to pay attention to what's happening here. Okay, so what do people do when I say they put DeFi services on Ethereum? What exactly are we talking about? So this is just a sort of broad categorization. There's definitely way more going on than this, but this is the things that are probably the most popular. So the first thing is you have something of value. So think of it as an asset. So the basic asset that you get with a blockchain generally, like say Ethereum, is you have a currency that's built into the system. So it's called ETH in Ethereum. So that's there. You can own ETH. You can trade ETH. You can do it just like sending an email. You just, there's no restrictions. There's no hours. There's no geographic restrictions or anything like that. You can just pass it around. Then in addition to it, what companies do is they release what are called tokens. And a token is something that's sort of custom to a specific protocol. And so you might need that token in order to access the protocol. You might need that token to try and make changes to the protocol that the protocol allows you to change by token holders and things like that. So there's lots of these tokens also that are floating around. Then what people want is I want to have Canadian dollars or US dollars on a blockchain. And you don't have that. And so the next best thing you have is called a stable coin. So my colleague Didem will talk more about stable coins later. But basically what happens is you have a company and a company says, I'm going to lock up $1 billion US dollars. I'm going to issue 1 billion tokens and these tokens are worth $1. If you end up with one of these tokens in your hand and you want your actual dollar back, then you can release it to us and we'll send you the actual dollar into your bank account. So these are called stable coins. There's also this concept of the blockchain doesn't know what's going on outside of the blockchain. And so oracles are this idea of taking data that's off-chain and moving it on-chain. So for example, what's the exchange rate between ETH and US dollars? The blockchain may not know that. Okay, so then an oracle is kind of like a trusted party that brings that information onto the blockchain. Now they have the rate, then they can set up a market that allows you to exchange. With tokens, you can also do all sorts of fancy things. So there's a lot of work on doing derivatives. It could be options. It could be a kind of future style security and derivatives, basically. And same with stable coins. You could have this concept of, well, could I have Google shares on a blockchain to trade? So no, you don't literally have Google shares, but you could have someone that tries to bridge them on. So they give you a token that should have equivalent value to a Google share, and then you can do whatever you want with it. Now, the main thing with this is when you're actually operating on chain, there's no regulation. Okay, so anyone can do it. I can decide I want one of these synthetic Google shares. And once I make that decision, I know the right website to get it, I can have it in my hand in 30 seconds. Okay? I don't have to register. It doesn't have to know who I am. It doesn't know my name. It doesn't know anything. Okay? I just get it. Now this is kind of changing. Okay? So there's also a parallel industry of centralized services. So these are businesses, but they hold all the stuff in their own hands. They're regulated, okay? So things like Coinbase or ShakePay in Montreal, those kinds of things, they're regulated companies. But what I'm talking about here is purely on-chain companies, but regulation is sort of coming to these companies as well. Okay, so once you have all these assets, they're all floating around, then what you want is you want the ability to trade them. You might trade them with leverage or margin. Leverage meaning that you want 5 times exposure to the price of ETH relative to the price of US dollars, for example, or something like that. And then margin's the idea that someone has to take on risk. And so you might go bankrupt, if the price just drops a little bit because you're over leveraged. So anyways, all of this is sort of managed on chain. There's also concepts of borrowing. Because it's anonymous, no one knows who you are. So no one's going to give you a loan based on your reputation. at least today. Okay, that might change with identities and stuff like that going online. But what happens is it's just over collateralized. So I want to borrow $1,000 worth of ETH, I have to put up $1,500 worth of Bitcoin, and then I can do that loan. There's also this concept of flash loans. Flash loans are very cool, and they're something that's sort of unique to blockchain that you don't normally have. You can actually, there's no real world equivalent, but anyways, it's kind of a very niche topic, so I'm not going to go through that. Once you have exchanges, you have lending pools and things like that, then in order to use these services, you're paying interest rates. Okay, so there's interest rates to the people that are providing the tokens that go into these services. And so once you have interest rates, you have the ability to make money. If you want to make money, then this is called investing, or yield farming is the fancy kind of term. And so you supply your tokens. Other companies will figure out where to put them to maximize your return, and they'll try and earn you some sort of return. The final thing that I'm not going to talk a lot about, but it probably will come up during the day and you can ask me questions, is these DAOs, decentralized autonomous organizations. And so what a DAO is it's basically a governance protocol for whatever you want it to be for, but let's call it for these services themselves. So for example, let's say there's a lending service and they don't know what the interest rate should be. What they'll do is they'll release a token that's kind of like shares in the company, and there'll be a voting process, and the voting process will happen on chain. And so what people will do is they'll sort of argue about what the exchange rate will be. They'll set up a kind of election. All the people that have these shares will vote, and then whatever the result is, it automatically, there's no human involved. It just, it triggers the right result, and then the interest rate gets adjusted to whatever it is. Okay, so anyway, these DAOs are sort of a lot of interest. Okay, so let me pause from this and just kind of tell you a story. So first off, this is a picture of a vending machine that sells you cars. Okay, now this picture is actually a bit of a gimmick. Okay, it's not literally a vending machine where you could walk up, put your credit card in, and a car will pop up. It's more like a dealership. You go in, you do all the paperwork. Then the dealer walks you over to the machine, and then they help press the button, and then the car comes out. And so it's sort of a gimmick. But imagine you had a literal vending machine like this. What would your concerns be? I mean, these are pretty expensive assets that are just sitting there. If it's a true vending machine, it's just sitting there. Anyone can go any time of day. You can go in the middle of the night. If there's any kind of security problem with it, right, someone could go away with 40 cars. Right? That's a lot of assets to leave sitting in something. So normally we think of vending machines for chips and pop, because worst case, if someone breaks in, they get a couple $100 worth of things. Okay, but this is a very different kind of proposition. Okay, so let me tell you another related story, and then I promise this has something to do with Web3 in the end. Okay, so this is a video poker machine. It's called the Game King. You can see that there's some fancy marketing to try and entice you to want to play with it. And, oh yeah, sorry, here it is. Full of new enhancements, including state-of-the-art video graphics and enhanced stereo sound, blah, 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 blah. Okay, so the guy on the top, his name is John King. He was very good at the piano, and he was also a gambling addict. He loved video poker. He would play it. He played it so much that the people who made Game King, they actually gave him his own machine. They said, hey, you can have this machine. It's just pretend money when it's his own machine. But he set it up in his house, and he would play it all day long. Okay? And he played it so much that eventually he realized there's a very subtle security flaw in the way that the game works. So what happens is that you're kind of playing the game, and you're sort of playing it at like the 1 cent level or the $1 level. There's different levels that you can set. And what you can do is mid-game is you can kind of switch, whether you want to play at 1 cent to $1. And what he realized is that there's this one kind of scenario in the game where you actually have more than a 50% advantage. So the advantage is to you, the person playing the game. Normally, the game's going to be set up so you're always at a slight disadvantage. But there's this one scenario where you can realize that you have an advantage, and then what you can do is you can switch the denomination, and the machine will let you do this. okay? So what he would do is they would play forever, they would create this scenario where they had a slight advantage, then they would crank the money up. They would win 51% of the time, 50.0001% of the time, whatever. But over time, if you play it enough, eventually you get a positive return. So he had this partner, Andre Nestor, and they went around Las Vegas and they found where these things were. There were some casinos that had them, so there would be racks of them in casinos, but it was also the kind of thing that would be in like a convenience store or a gas station, that type of thing. So they were all over. And we don't actually know, the police don't know what all, how many of these machines they hit, but they do have surveillance and other things to show that they hit a handful of them, and they netted at least about $500,000 from going to these vending machines. Now, I already said the word police, so you're thinking, okay, why are the police involved? And so it actually became this very controversial case because the police laid charges against them. Their defense was, it's coded that way. You know, I was just playing the game. I mean, if the machine wants to give me this advantage, right, then that's part of the game. Right? I just came up with a winning strategy and I won it. And the police are like, no, that's unauthorized, it's theft. And so it was this big contentious court case. Eventually it got settled before it actually reached. So we don't have a judicial decision on it or a precedent for it. But the Crown eventually agreed to drop the charges, and they agreed that this was considered authorized access to these funds. Okay, so DeFi services are very, very much like the car vending machine, or they're like this video poker machine, okay? They're autonomous smart contracts. They're just sitting on the internet. Anyone, anywhere in the world anonymously can walk up to them and they can start using them, okay? And if there's something like this flaw in the lottery machine, in a smart contract that's doing one of these DeFi services, then people will drain the contract of the entire assets of it. Okay, it might be $200 million, okay? And these things happen like 3 times a month. There's something over $1 million with one of these contracts getting drained, okay? So DeFi applications are kind of like vending machines. There's no humans involved or anything like that. You normally care a lot about internal controls when you look at companies. Here you don't have it. You have a public-facing interface. Okay, so you have external controls, and there's material value sitting there, and anyone can walk up from anywhere in the world over the internet. And because they're digital, they're very fast at settling. And so you can drain it in a minute. A minute later, it could be gone. You could have a contract that has, you know, $100 million, and 1 minute later, all the money is gone. It's not like the guys who had to go to all these video poker stores all around Las Vegas, right, and find all the machines. It's just like you can hit all of them all at once in one transaction, and you can be done. And so this is coming back. So this was a case that involved a University of Waterloo student where I did my PhD. And this person was charged because they found kind of like a security vulnerability. They argue it's just like the poker case. Okay, there was a DeFi service, there was a bug in it. I got $50 million out of it. Too bad for the DeFi service. And the DeFi service is saying, oh, no, that's against the law. That's an exploit. You know, it wasn't intentional that was there, and so that was an exploit. And so this has not gone to trial yet, or it's, you know, this is still pending. And so this is one to watch if you're interested in this stuff to see what actually is going to happen in this particular case. And the other thing, I'm not going to walk through this diagram, I'm just showing it for its impressiveness, is a lot of these attacks are super sophisticated too. It's not just as simple as walking up to one service and draining it of all its money. Often what you do is you walk around to 4 or 5 of these DeFi services, somehow you do actions in all of them, and at the end of the day, you net a certain amount of money. And so this was one. I have other talks online where I walk through this whole diagram if this really strikes you of interest. Okay, now I do want to offer one sort of level of criticism to DeFi. And so when I look at DeFi, I do find it a little disappointing because I find it's very circular. Okay, so you have these DeFi services, they launch tokens, and then in order to trade the tokens, you have all these fancy DeFi services, and then they launch tokens, and then you want to trade them, so you need more fancy ones. And it's just like completely sort of internal. Okay, so it's just a bunch of crypto people trading crypto stuff using crypto technology. Okay, so what I'm always interested in is when does it kind of break out of its own, trading its own stuff and actually try and touch the real world. Okay, so things like stable coins are one example where you bring US dollars on chain, but a lot of times they're also just used internally. It's just like, I want to get out of a financial position really fast, so I buy stable coin instead of trying to pull the money out of the system itself, because that's slow. It will take a couple days. I have to use identification and things like that. This idea of synthetics, which would be like an actual share of Google that's on a blockchain, they're not really used. I was excited about this use case. I thought that maybe this would be like the killer app that DeFi is looking for, but it turned out to as of yet, so it might change in the future, but there's almost no interest in these things. The trading volumes are way less than all the internal speculation that happens. And then the other interesting aspect that's sort of boiling at this point is the idea of maybe the government will do a Web3 kind of equivalent. At most, they might do a payment system that's digital. They might do a currency that's digital. So this is called a central bank digital currency. But they could also just provide a whole infrastructure that would be similar, where people who have ideas of how to use your Canadian dollars that are now digital, here's a digital service, I have this idea, and they would be able to create this app, and it would run sort of autonomously. Okay, so CBDCs are now like one of my main research areas. And since there's a lot of like I mentioned, legal criminology like type of people here, I thought I would spend the second half of the talk just talking about CBDCs and kind of how it intersects with the law. So this is joint work. So Didem's in the back. She'll be in a panel a little bit later. And then I have some colleagues, Rainer Bohm and Raphael Auer, who's at the Bank for International Settlements. And what we're looking at in this project is Rainer, Didem, and I, we're kind of crypto people. And we thought, okay, CBDCs need some form of privacy. We're crypto people, we can figure out, we can do all sorts of fancy things. We can do zero knowledge proofs and all this stuff. But what we struggled with is, what's the basic definition of privacy? What should privacy look like for a CBDC? And we couldn't agree on what it should look like, because you have all these sort of tensions between what law enforcement wants, what banks want, what users want. And so anyway, this ended up being just an exploration of kind of the privacy options that you could have. So the basic idea of a CBDC, before we get to the privacy question, is you are a person or you're a company, you have a bunch of money, you move it into a bank account, okay? So now your money is sitting in the bank, okay? But the money isn't like just literally sitting there in a safe. That's maybe the concept that you have initially. What happens is the bank kind of does different things with it, okay? So what it will do is it's allowed to take your money and do things with it to try and earn profit for itself. Okay, so the money's not just sitting there waiting for you to come back. So regulatory requirements will say a certain fraction, depending on either a reserve requirement or a capital requirement in Canada, a certain fraction needs to go to the central bank, and there it will literally be the equivalent of sitting in a safe. Okay, but it's a very small fraction of the money. Okay, the rest of it the bank can do something with. Now, the federal government says, okay, this is risky. What if the bank loses money? We see it happen in the US all the time, right? Then is everyone's money gone? And so the federal government will say, we can't have that. So we have to set up an insurance scheme, okay? And all the banks will contribute to it. And if there's ever a problem with a bank, and it, like Silicon Valley Bank or something like that, then the insurance will kick in, okay? Now, the insurance for you and I is probably sufficient. But if you're a firm and you have lots of money, lots of cash, then the insurance isn't going to cover all of your cash, okay? So then in addition to the amount that the insurance covers, you're going to have the cash that's in excess of the insurance. And you can, go to different banks, and, there's certain ways to try and manage this. But basically you have kind of like you have three piles. You have the money that's safe because it's at the central bank. You have the money that's safe because it's insured, and then you have the money that's not safe, that's really at risk at the bank because it's not insured and the bank is doing things with it. And then there's all sorts of regulations about what banks are allowed to do, and that's going to differ from places like Canada or the US. Okay, sorry, I'm missing the killer slide, which is the next one for some reason, but I'm going to just describe it. Okay, what happens in a CBDC? So in a CBDC, think of that, instead of going to the bank, what you do is you just own digital money that's given to you by the government. And so it's almost like that green part, that little fraction that's stored at the central bank, that's your whole thing, okay? That's the whole bar all the way down. So you can put unlimited amounts of money into a CBDC. There's no bank in the middle, and it's going to be just like you're parking it at the central bank. You're never going to lose that money unless if the central bank, like the country, goes bankrupt or some very super extreme scenario, okay? Extreme for a Western democracy anyways. So that's the promise of a CBDC. Now, there's all sorts of different CBDCs. So some people like them, some people hate them. If you talk to them long enough, you realize that they like or hate it because they think it's going to work a certain way that's not necessarily true. Okay, so there's different ways you can do it in terms of how does it derive its value? Are the banks still involved? Are they sort of middle people that are giving you access, or is it direct access through the central bank? Are you going to do fancy Web3 things with it? Is it going to be just a strict payment system? What kind of identity requirements are going to be in place? Can my kids hold a CBDC, or do you need a government identification, photo ID? Do you need an address, right? What if someone's visiting Canada from overseas? They don't, they have a passport, whatever the requirements are to enter the country, but they're not a citizen, they don't have a residence here. Are they allowed to hold a CBDC? How do we control it? Can someone who's not even in the country, right, that's in another country, can I send CBDC to them? So there's all sorts of really complicated questions that are really going to shape it. And then there's the question of privacy, okay? So is this going to be anonymous like banknotes? Banknotes are given to us from the central bank, right? They're fairly anonymous. We'll think about that in a second. Or is it going to be like the current banking system that we have, where everyone's identified, all transactions are traceable, they're reversible if necessary? Okay, so what we want to do is sort of zero in on this question. And so the first thing we said, okay, what are people saying? Are people saying anything about privacy? And everybody raises the point that privacy is important. We got to figure this privacy thing out. It's going to be the most important part. But no one has an actual solution, right? They always sort of say, oh, it's for someone else to figure out, right? So the IMF says, they basically just identified there's this trade-off between users' preference for privacy and the risks to financial integrity. The Bank for International Settlements calls it a challenge. It says it needs to be considered carefully. There could be difficult public policy design choices for a central bank. So it's important. We got to figure it out. It's not going to be us. I guess it's a public policy thing. The Digital Dollar Project, which is a project from people from the CFTC in the US that are proposing it. They want a balance between privacy and compliance and regulation, and the policymakers are going to decide it. Okay, what's that right balance? We'll give it to the policymakers. And then here in Canada, the Bank of Canada, they also say at the very end, how much privacy should be available and from whom is an important public policy issue. Okay, so then you go to, so these are actually kind of public policy people. I mean, they're organizations and institutes. Some of them are government associated, but a lot of them are either lobbyists or people who directly create policies. And they're all saying that someone else, some other policymaker should do it, or we should give it to the public. And so what's happening is everyone knows it's important, but no one's trying to figure it out. Okay, so we sat down and we said, okay, let's try and see at least what the options are. Let's just play around with it a bit and try and understand it a little bit better. So we realized that there's all sorts of stakeholders that have all sorts of different competing views, but most of them can be captured with three kind of key stakeholders. So you have the privacy enthusiast who wants privacy. You have law enforcement. It should be obvious why. And then the other piece that maybe a CBDC gets rid of, but it's at least should be part of the framework, is currently there's a lot of people that make money from having access to financial information, okay, including your bank and other financial companies. So we call these sort of the data holders. Okay, and then everywhere there's an arrow shows that there's a tension between these two parties. So the one party doesn't kind of like what the other party is doing. Okay, so data holders, for example, they're not crazy about law enforcement because law enforcement are always coming to them saying, you have to report suspicious transactions, you have to do KYC, you have to, investigate things, and we have a warrant, and you have to dig up this information, and we have another warrant, and you have to give us a user interface so we can do it really fast. So for the data holders themselves, there's friction between them and law enforcement. The data holders fight amongst themselves, right? They all want the data, but they want to be the only ones to have the data. If everyone has the data, then it's not useful anymore, right? So it's only useful if it's proprietary. Privacy enthusiasts don't like having data holders. So the greatest furor was probably when Facebook said, hey, we're going to do a stable coin. And everyone thought Facebook, like they're the last company on earth that we want to have access to all of our payment information. And the US Senate, and you saw like a huge regulatory response in the US. Then in terms of law enforcement, I mean, privacy enthusiasts, they want to live in a society where crimes can be solved, right? But you have to balance that with some aspect of privacy, and then the flip for law enforcement. They want access to whatever can make their lives the easiest, right? Whatever can make investigations have the least amount of friction. But privacy enthusiasts are worried about overreach, okay? And you can think of this situation like kind of where you would fall living, say, in Canada, right? But is that going to be the solution for every country you can think of in the world, right? It's the overreach of police in the state could vary a lot depending on where you choose to live. The other thing we thought about is we tried to think about solutions, okay? And so what we came up with is we realized that solutions were kind of they were kind of getting split in two dimensions. Okay, so the first is what we could do as cryptographers. Okay, there was a lot of fancy things that we can do, and we can really lock data down so like nobody will ever know that for a million years. Okay, so anytime you want to use cryptography or things like that, we call that hard privacy because it's very hard, it's rigid. And then there's the current regime of using laws and regulation. Okay, the data's sitting there, someone could access it, but they need a warrant or they need to go through some process. So that we call soft privacy. Then on the converse side, we think of the auditability being soft or hard, which depends on like how rigid is the rule that you're writing about whether you have access to it. So soft auditability would be kind of like human discretion. A judge looks at it and says, yes, you can have access in this case, or no, you can't have access. And hard auditability would be something like if the transaction amount is $10,000 or more, you can access it. If it's even a cent less than $10,000, you do not have access. So it's a very clear line. It's a machine decidable line, okay? And so to do hard privacy, you kind of need hard auditability. The two of them kind of work side by side. So we can start filling in kind of the quadrants. And so most of what we see falls in soft privacy and soft auditability. So like, for example, there's an investigation. You have to report a suspicious transaction. There's no definition of what suspicious means. Okay, it's left to discretion. Okay, that's soft auditability. On the converse side, you can think of the hardest of the hard, right? Like hard privacy combined with hard auditability. So you could have things like transactions over $10,000 cannot be accessed. Everyone has $10,000 a month, they can use it. On the extreme side, you can have full anonymity. So things like Zcash, like you can't see anything. There's nothing to be seen. And you might think that this extreme quadrant of full minimal auditability, basically being that there's nothing there to see, you might think that that's very restrictive for law enforcement. But it actually turns out it's not so bad. It's kind of like cash. And law enforcement actually have a lot of ways of dealing with cash. So they can watch ATMs. They have surveillance cameras. Cash has serial numbers on it. They can look at fingerprints or mark bills. Then they can always they can find someone who witnessed the cash transaction, right? If someone witnessed it, then that's fine, right? So they can obtain records. Usually when you have cash, you also have a secondary record because the payment system isn't keeping a record for you, right? So they'll find the notebook or whatever where the spreadsheet where all these operations are being mentioned. And then if you use an anonymous CBDC, it would be sort of similar, okay? So you could still use witnesses, you could still use secondary records, You can still go undercover. Plus, you can do things like trace IP addresses. You could put malware on a computer, and then it would know what the user is doing. You could actually go physically. You search a premise. You take their computer, and the RCMP do this, right? The first thing they do is, what are all the wallets that are on this computer? They find it, and in the wallet will be all the addresses that are using. So anyway, so you're not like completely helpless even if you want to do this sort of extreme quadrant. Then what's interesting is, what about hard auditability and soft privacy? So if you already have ways of doing soft auditability using discretion, then you don't need hard auditability as well. It seems redundant because whatever you get in the hard auditability, you could also get just through soft auditability. And what happens is that a lot of measures are kind of a layer. So everything is available at a discretionary level, but it takes a long time. You have to get a warrant, whatever, okay? So then for things that we think are highly, like law enforcement really want to pay attention to, it's highly useful, we add a second layer, which is just automatic, that you automatically have access to that, and it's a fast process, and you don't have to talk about it. So, for example, if there's transactions that are over $10,000 within a month, or there's some red tape with it, but basically it gets reported automatically to FinTrack. Okay. Does that mean that if there's a transaction under $10,000, the law enforcement will never find it? No, it's just not automatically reported. They have to go then through the slow path of the soft auditability and get a warrant and get access to that information, okay? So anything that you can write down like a logical rule, a rule that a computer could understand, we put in this quadrant. So like you're not allowed to send money to this person or this country. This person is allowed to buy that derivative because they're on a list, but there other people, if you're not on the list, are not allowed to buy that derivative. This transaction's over $10,000, that kind of thing. Okay, and we can use crypto in this quadrant as well. Okay, so because we have hard rules, then that's fine. Then the sweet spot is kind of this hard privacy where things are locked down with cryptography, but we still have the soft auditability of if there's discretion and someone wants to look at it, then they're able to look at it. And one of our messages is a lot of people, like in policy circles, they talk about what they think will happen in this space. And we kind of have to go around pouring cold water and say, you can't really do that with crypto. Crypto is very binary. Like either you have the key or you don't, or these 10 people have the key. If they have the key, they can decrypt everything. If they don't have the key, they can't decrypt anything. Okay? So it's very yes, no. You can't have like, oh, that's decryptable because a judge decided that it could be decrypted. Okay? There could be a key, so they could say you can go and use that key, but if you had access to that key, like say there's a data breach and someone got the key, it would decrypt everything. It doesn't matter what the judge says. Okay? So anyway, so there are some fancy things like you could think of, what if you kind of do machine learning under encryption or blah, 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 blah. So maybe in 20, 30 years, like I'm not saying it's absolutely impossible, but this right now is like pretty science fiction. And so what we want to do instead is we want to look kind of at the lower right quadrant. Then what we did is we kind of went through what people are saying in this kind of lower right quadrant. And there's a bunch of primitives. I won't go through the whole chart. But the main message of this is we asked ourselves, what crimes do these actually solve, right? Like, let's say that you can see every transaction over $10,000. Okay, that's great. If it's under $10,000, then it's full anonymity. So that's a rule. It's clear cut, it's logical, we can enforce it with cryptography. Okay, great. Is that going to help you with, I don't know, money laundering? Maybe. Maybe that's a useful tool for money laundering, okay? Now, let's say I pick up my phone and I have an Amber Alert because there's a parent that kidnapped their child and they stopped at a gas station and they filled their car up with gas. And law enforcement wants to know what gas station that was because then they have a physical location and then they can put highway patrol people out to try and find that person, okay? Let's say in that scenario, is that transaction over $10,000? No, it's not. It's $30, right? It's $40. It's exactly the kind of transaction that you would probably think should be private, right? Like, why does the government have to know every time I fill up on gas, right? They shouldn't. That should be private. But if you construe the right circumstances around it, it could actually be a critical piece of information for a particular criminal investigation, okay? So anyways, what we did is we tried to, brainstorm, and none of us are like criminologists or anything like that. So this was bad, but we're now collaborating with someone who is. So we're hoping to like clean this up. But this was just sort of a rough first pass of the different kinds of crimes and the different kinds of rules and whether the rule actually does something useful for this particular crime. And I have to say that the CBDC people are very focused on money laundering and counter-terrorist financing. Okay? The reason they're focused on it, the answer is right here, is because they have that quadrant. So there's already rules that are hard, audible rules, and so they're like, okay, that we can wrap our heads around, and so we'll focus on those types of things, right? But no one's taking a broader view of crime and looking that there's more to crime than just money laundering and terrorist financing, okay? And then it gets really hard and discretionary how you want to try and solve it. Okay. So those were the two main messages. We have an article, you can find it on my website, and we'll have a longer, hopefully, BIS working paper soon that goes through all the details of this research, and happy to answer more questions about it. So those were the two topics that I kind of wanted to bend your ear about, and I think we have some time for questions, and so I'll stop it here.